having the class interval like this. Okay, or maybe like this. Then class mark means lower limit plus upper limit by 2. Here the lower limit is 0 and the upper limit is 10 divided by 2. That means 10 by 2. And the answer will be 5 for the first class interval. For the next class interval, class mark just like that will find lower limit plus upper limit by 2. Fifteen. This is how we are supposed to find the class mark. Okay, actually this class mark, if you will see carefully, it is representing the midpoint. In between 10 and 10, there is a 0 and 10, there is a number which is 5, right?
Yeah, ma'am.
Similarly, in between 10 and 20, there is a number which is 15, right?
Yes, ma'am.
So class mark means basically we are finding the midpoint of this class interval. Making sense?
Yes, ma'am.
Okay, and you told me what is class length, right?
Class width, ma'am.
Class, you call it class width, you call it class length. Whatever you say, it's the same thing. So if you will
Okay.
be finding class width, the formula is upper limit minus lower limit. Upper limit is 10 and the lower limit is 0. 10 minus 0 is 10. So class width for this class is 10. For the next class interval also, if we will find the class width, that will also be the same.
Okay, ma'am.
Upper limit minus lower limit. That is 20 minus 10, that is 10. Clear?
Yes, ma'am. Yeah, ma'am.
Yeah. That's the difference between class width and the class mark. Now, today we are supposed to discuss histogram. So let me take it.
Yes, ma'am.
Suppose our data looks like this: 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Okay, actually, your data directly starts from, let's say, 20 to 30. Okay, then 30 to 40, 40 to 50, 50 to 60. This way the data is there and the frequency is given over here. Here 7, here 8, here 12, here 13. Okay, and the question is asking you to draw the histogram. So first of all, before drawing the histogram, we need to check whether our data, this class sizes are same or not. I mean this class size, this class size, this class size, and this class size. If all these class sizes are same, then directly we can go ahead and we can draw the histogram. How? We just need to write this data, this class intervals, we need to write along x-axis. Okay, 20, 30. Yeah, 10, 20, 30. You will be taking properly. 10, 20, 30, 40, 50, like that. Okay. And the frequency always we will maintain along y-axis. So you can take the gap 2, 4, 6, 8, 10, 12, okay, 14, like that. Now you will be just, you need to make the bar graph, okay, that in between 20 to 30, it's going till 7. So we will take till 7 here. Wait. Like this. In between 30 to 40, it goes till 8. In between 40 to 50, it goes till 12. So this is our, okay, when the bar graph are attached with each other like this, and the figure looks like a solid figure like this. If your figure looks like this, then you can say it's a histogram. Actually, the way you are having your name, the way I am having my name, this type of bar graph which is just attached with each other, okay, are called histogram. Clear?
Yes, ma'am.
While drawing the histogram, if your data starts from 20 directly, not from 0, then here you need to draw a kink or a break like this. Okay, like this, you need to draw a kink or a break. Let me highlight it.
Yeah, ma'am. That's what I told you last class. This symbol, this one.
This is called a kink or break. We will not draw
Oh,
this kink or break when our data starts from 0, 0 to 10, 10 to 20. If it starts from 0, we don't have to draw it. If directly you are jumping to 20 or 30 or 300 or 400, you need to draw this kink or break while drawing histogram. Clear?
yes, ma'am.
Okay. Now the next thing over here is, if your class and okay, this class sizes, I was talking about that our class size needs to be same, and the data needs to be continuous group data, then only the, okay, without thinking about anything, we can just draw the histogram. This data 20 to 30, 30 to 40, 40 to 50, 50 to 60, it was continuous. What does that mean? Continuous means 20 to 30, 30. Okay, then the next data point start from 30 to 40, so it is continuous, right?
Yes, ma'am.
If the data is not continuous, then what we will do, that's what, okay, I'll be explaining. And one more thing I'll be explaining, if the, suppose the class sizes are not same, then what you will do. So far, any confusion, Nikhil?
No, ma'am.
Okay, next part is, if the class size is not same, suppose our data looks like this. Just a second. Let me scroll. One condition is there which needs to be fulfilled while drawing the histogram. And the condition is area needs to be proportional with the frequency. Okay, area has to be proportional with the frequency. What does that mean? That mean, I'm coming to the explanation. Area needs to be proportional with the frequency. That means that if you are drawing the histogram, okay, just now we have drawn the histogram, our data started from 20 to 30, and then 30 to 40, and then 40 to 50, and whatever was the frequency, okay, randomly I'm taking, suppose the frequency was, let's say frequency was 7 over here, and here the frequency was 12. 12. Okay, here till 7, here till 12. Suppose this is how the frequency we are given. Now the rule says that in histogram, always this condition needs to be fulfilled. Area is bigger than, I mean, area is proportional to frequency. Area is proportional to frequency. What does that mean? That means that if you will find the area of this rectangle, your area will be length into breadth. Okay, you can see the gap between 30 to 40 is 10 and it is going till 7. So length into breadth, area will be 70. Making sense?
Yeah,
And next area will be
ma'am.
length into breadth. Okay, 10 into, yeah.
Ma'am, isn't it 0 to 20 the value of 7 like has the frequency of 7? 30 to 40 has the frequency of 10, ma'am.
I'm not talking about this example. Okay,
Oh,
I'm
okay,
not
ma'am.
talking about it. I'm just taking one of the random example and I'm telling you to focus over here.
Okay.
Okay, so if the frequency and the figure is given like this, then we are just trying to find the area. Area will be 10 into 12, that is 100. Okay, now
Ma'am, one
area,
minute.
yeah.
Sorry.
Am I audible?
Yeah, ma'am. Sorry, ma'am.
No worries, let's continue. So I'm saying that here area is proportional to frequency means can you see that our area A1 it's is smaller than the other area? Can you see? This one is 70 and this one is 120. Can you see it is a smaller?
Yeah, ma'am.
Okay, that means the frequency, this frequency F1 needs to be smaller than F2. Is it that? Is it getting fulfilled? So yeah, it is a smaller.
Yeah, ma'am.
That's the meaning of area proportional to frequency. If area is bigger, the frequency will be bigger. If the area is smaller as compared to other rectangle, then the frequency will be smaller as compared to other interval. Making sense?
Yes, ma'am.
Okay, that's the meaning of area proportional to frequency. Okay, proportional means direct proportional. Direct proportional means if one is increasing, another will increase. If one is decreasing, another will decrease. Clear?
Yeah, ma'am.
Okay. So this is talking about there must be a direct proportional relation between area and frequency. And yeah, this is getting fulfilled in our example. Yes or no?
Yes, ma'am.
हमने देखा कि you understand Hindi, right?
Ma'am, little bit I can understand.
Okay, no need to. Uh, okay, we have clearly seen that the first area is smaller than the second area. And yeah, it is true that the first frequency is smaller than the second frequency. Okay, so yes,
Yes, ma'am.
in this example, everything is getting fulfilled. The important condition for histogram, area proportional to frequency, that is getting fulfilled. But in the example which you can see now, okay, which you can see on the this left end, if I'll mark that 0 to 20 and 20 to 30. So 0 to 20, the frequency is 7, and 20 to 30, the frequency is 10. If I just find the area and will show you, so here area 1 will be length into breadth, basically 0 to 20, 20 and into 7. Area will be 140 and their area will be 20 to 30, 10 into 10. That means area will be 100. Now can you see area 1 is bigger than area 2?
Yeah, ma'am.
Okay, that means frequency 1 must be bigger than frequency 2, right?
Yes, ma'am.
But it is not the case, right?
Yes, ma'am.
Okay, that means here we cannot go ahead like this and we can draw the tables because I was telling you all the class sizes needs to be same, and clearly can you see the class sizes are not same.
Yeah, ma'am.
Okay, this the condition which you have seen that area proportional to frequency, that is getting invalid. This will only happen when your class sizes are not same. just like this. Our class sizes are not same, hence this problem is occurring. And if the class size is not same, then what we need to do, we need to work with the data before proceeding with the with drawing the histogram. We need to customize the data. Are you understanding?
Yeah, ma'am.
Okay, why we will customize the data? Because class size is not same. Why it is hampering? What problem it is creating? So since the class size is not same, and due to that, the one and only one, the most important condition for histogram, area proportional to frequency, it's not getting fulfilled. Clear?
Yes, ma'am.
Okay, so we will work with the data. First of all, we will find the length of each class. Okay, you call it width, right? You call it length, you call it width, it's the same thing. So width of
Yes,
the class. Upper limit minus lower limit. Upper limit minus lower limit, it will be 20. Next, upper limit minus lower limit, it will be 10. Next, upper limit minus lower limit, it will be 10. Next, upper limit minus lower limit, it will be 10. Next, upper limit minus lower limit, it will be 10. And next, upper limit minus lower limit, it will be 10. Clear?
yeah, ma'am.
Okay, few more data is there, but let's see with this much only. Now we have to change this frequency, okay, which we call as a length. Okay, length means the rectangle is going up and up and up and then coming down. So it became the length of the rectangle. Can you see?
Yeah, ma'am.
Okay, actually this frequency is working like the length of the rectangle. So we will say length of each class we are going to change. Length of class we are going to change. How we will change? So we will change it. One day I was explaining about the unitary method and I was telling you that if 7 orange price is given as rupees 20, and if you have to find 1 orange cost, you will be doing the basic division, right?
Yes, ma'am.
Okay, I mean, let me take it reverse way. Just a second. Because I want to change the length. Just a moment. I mean, if suppose 20 orange price is rupees 7, then 1 orange price will be 7 by 20, right?
Yes, ma'am.
Okay, and the price can be in decimal. 0 point something, yeah, 0 point something, it is possible, right?
Yes, ma'am.
Okay, we do get such a packet of chocolates or toffees where the complete packet we get in such a small amount, right?
Yeah, ma'am.
Okay, so 20 oranges cost is 7 rupees, so 1 orange cost will be 7 by 20, right?
Yeah, ma'am.
Okay, and what about the price of 10 orange price will be 7 by 20, 1 orange price into 10, yes or no?
Yes, ma'am.
Okay, same concept we are going to use over here. We will say among all the class width, okay, this 20, this 10, this 10, this 10, this 10, this 10. We will fix the bare minimum, the least. 20 is there, 10 is there, 10, 10, 10, 10, 10 is there. The least one is 10, right?
Yes, ma'am.
Okay, so we will fix the least one and then we are going to use a method which is somehow same like the unitary method only, but we don't take it that deeply. We just say that we are going to use the method, okay, for changing the length of the class. And the method says that we have to take this frequency by this width into this one and only one which you have fixed, the least value of the width, 10 we have fixed, right? 10
Yes,
we have
ma'am.
fixed, okay, because that is the least. So into 10, making sense? If you are thinking from where this rule is coming, unitary method, getting it?
Yeah, ma'am.
Okay, this is how we are changing the length of the class. Okay, that when the width is 20, frequency is 7. Okay, that way, just when it is 1, the frequency will be this, and then when it is 10, the frequency will be this. Making sense?
Yeah, ma'am.
Okay, then all this, the throughout the column will be doing the same thing, just to change the length of the class. Again, why we are doing it? Because the area proportional to frequency, that condition was not getting fulfilled. So quickly we will write 10 by 10 into the number which we have fixed, sky one. Okay, next.
Ma'am, so we have to do frequency by width of the class is equal to
Yeah,
the length of the.
frequency by width of the class into the least width which you have fixed. Making sense?
Yeah, ma'am.
Every time you have to do the same. So 10 by 10 into 10. Similarly, 20 by 10 into 10. Okay. Similarly, this 20 by 10 into 10. Okay. And we'll do the calculation. We'll be getting 10 2 times 20. Here you will be getting 3.5. Here you will be getting just 10. Here you will be getting just 10. Here you will be getting 20. Making sense? Here
Yeah,
you are
ma'am.
getting 20. And this time, rather than taking that frequency, now you will be taking 3.5, 10, 10, 20, 20 while plotting the graph. And your graph will look like this.
Okay, ma'am.
This is how your graph will look like. You can clearly see that here what has been taken, like we have not taken the actual frequency. We have taken 3.5. Can you see? 10.
Yeah, ma'am.
Again 10. So now the condition area proportional to frequency, you can clearly see here area 1 will be length into breadth, that means 20 into 3.5, that is 70. And area will be length into breadth, that is 10 into 10, that is 100. Now area 1 is smaller than area 2, that means frequency 1 will be smaller than frequency 2, right?
Yes, ma'am.
Okay, and it will get validated with the actual frequency as well, the original frequency which was given without the customization and all. Area 1 is smaller than area 2, that means frequency 1 will be smaller than frequency 2. Can you see your frequency 1 is already smaller than frequency 2?
Yeah, ma'am.
So previously this condition was getting invalidated, now it is valid. Clear?
Yeah, ma'am.
Okay, so this is how we'll be working with the data. Now the next, so far any confusion, Nikhil?
No, ma'am.
Okay, so always while drawing the histogram, you can just check if the class sizes are same, class size, then go ahead and draw the figure without doing anything at all. Okay,
Okay, ma'am.
if the class size is not same, if the size of the class is not at all same, then yeah, you have to draw extra columns and all, and you have to do this customization. Okay, in MCQ question also you will be getting such question that in histogram area is proportional to, you will say, frequency. Area is directly proportional or inversely proportional. Area is directly proportional to frequency, because inversely proportional means speed and time relations are inversely proportional. Suppose you are going from your home to your school. Okay, one day you are very like not feeling well or whatever, you are going slowly, you are just walking slowly. That day you will end up getting more time to reach school, right?
Yes, ma'am.
So when your speed is lesser, less means smaller number, then the time will be a bigger number. Making sense?
Yeah, ma'am.
And another day, if you are feeling so like energetic, you are going really fast, you have exam as well, you are rushing as well. Okay, you are going to, okay, fast and fast and fast. That means your speed is your speed is more. When your speed is more, then your time will be small. Making sense?
Yes, ma'am.
This is called inversely proportional. If one is decreasing, another is increasing. If one is increasing, another is decreasing. This is called inversely proportional. So here the area is proportional to time, that is directly proportional. See, proportional and directly proportional is the same thing. The way you know, Nikhil, that this means square root and this means square root, right?
Yeah, ma'am.
Similarly, proportional means directly proportional. Okay, proportional means directly proportional. So even though this terminology, just just directly proportional is written, that means one is increasing, another is increasing. One is decreasing, another is decreasing. Or maybe just proportional is written, just proportional. Then also directly word is hidden over here. Making sense?
Yeah, ma'am.
Okay, so yeah, you need to understand these basics, because a certain reason based question and MCQ question will contain that only. Now I will
Okay,
also
ma'am.
take when the data is not continuous data, then what to do. So yeah, you can see, just a moment. Just a moment. Suppose your data looks like this, which is not continuous at all. Then you are not allowed to go ahead and draw the histogram. Okay. If your data is like this, 118 to 126, 127 to 135, 136 to 144, 145 to 153, 154 to 162, 163 to 171, 172 to 180. Okay. If the data is like this, and clearly can you see it is not continuous, right?
Yeah, ma'am. Yeah, ma'am.
Okay, so you have to make it continuous before proceeding with plotting the histogram, or maybe a frequency polygon, which we'll be discussing after that. So first of all, we have to make the data continuous. Here the gap is 1. Okay, I mean the gap between this lower limit and this upper limit, it's 1. Similarly, the remaining gap, all the gaps are just 1 only, you can see the gap is 1. So what we do, we take the gap, okay, that is 1, and we divide it by 2. Always we divide it by 2. Yes, always we divide it by 2. And then whatever you get, here you will be getting 1 by 2 means 0 0.5. This 0 0.5, we subtract this number 0 0.5 from the lower limit and add the same 0 0.5 in the upper limit of the class interval. Okay, we subtract the 0 0.5 from the lower limit and add 0 0.5 in the upper limit. We subtract 0 0.5 in the lower limit and add same number in the upper limit. We subtract this number from the lower limit and add the same number in the upper limit. We subtract it from the lower limit and add it in the upper limit. We subtract it from the lower limit and add it on the upper limit. Okay, if this way we will keep on doing the calculation, then our data will become continuous group data. You can see 118 minus 0 0.5 will be 117.5, and 126.5 plus 0 0.5 will be 126.5. Next, 127 minus 0 0.5 will be 126.5, and 135 plus 0 0.5 will be 135.5. Making sense?
Yes, ma'am.
136 minus 0.5 will be 135.5, and 144 plus 0.5 will be 144.5. 145 minus 0.5 will be 144.5, and there 153.5. Here 153.5, here 162.5. Okay, now we are good to go ahead and draw the histogram, but before that we need to be assured that the class sizes are same or not. If the class sizes are not same, then extra two columns we have to make. We have to customize the data. If the class sizes are already same, we don't have to do anything at all. Okay, so here we'll have 171.5. You can clearly see for finding the class size, the formula is upper limit minus lower limit. If you will do upper limit minus lower limit, it will be 0. 16 minus 7, this is 9. And here nothing, just 9. Okay, the class here size is 9. Here also, once you know class size is 9, the first one, next one you can check in the same manner. 126 plus 9, 135, right? Right?
Yeah, ma'am.
Okay, similarly 135 plus 9. Okay, 144. All the class sizes are same. That's why we don't have to think about anything else at all, and we can go ahead and we can draw our histogram. While drawing the histogram, our first data, which is starts from 117. So yeah, here we will be drawing the kink or the break, which we draw like this. Okay, very teeny tiny. It looks really huge. It must not look this much huge. It's very small, like this. Making sense?
Yes, ma'am.
Okay, we are having 117.5 to 126.5. We draw the class interval, we locate it along the x-axis, and the frequencies we locate along the y-axis. You don't even have to check the frequency and the area relation anytime, anywhere. It will get fulfilled. If you have checked your class sizes are same, then yeah, it will get fulfilled. If you are thinking why it is happening, you think about it while finding the area of the first triangle. For example, okay, I'm not taking the same situation. For example, area 1 and area 2 is there. Now in area 1 and area 2, your class size is same. For this example, let's say the class size is 9 over here and the 9 over here as well. So one of the, okay, length, I mean the width of the class we have taken as a 9. Now the frequency. Okay, maybe the first frequency is 5 and the next frequency is 3. So both the class sizes are same. Okay, width is same in both the cases. Now the length we need to multiply for finding the area. Here the length is 5, here the length is 3. Okay, 9 5 times 45, and here 9 3 times 27. So can you see, completely it depends upon the frequency if the class size is same,
Yes, ma'am.
and hence the formula. Bigger the area, bigger frequency, smaller the area, smaller frequency. Of course, if the class size is same, bigger the area means bigger frequency, and smaller the area means smaller frequency. Yes or no?
Yes, ma'am.
Okay, that's why this rule is there. And why this rule is getting invalidated when the class size is not same? Because randomly, all of sudden, anything will start coming. Okay, that's why you have to customize the data. Making sense?
Yeah, ma'am.
Okay, so we are done till here. I need to take the frequency
Frequency
polygon as
polygon.
well. Now your task before the next class is to just practice all those questions. See, when you will open your NCRT, all the question is asking about draw a histogram, hence frequency polygon also draw it. Draw histogram, frequency polygon also you have to draw it. But I am telling you, please, not all the questions, but at least with 2 3 questions, try drawing the histogram first. Okay, just the
Okay,
histogram,
ma'am.
even though it says draw the frequency polygon after that, just skip that part and just draw the histogram and check, are you clear till here? Till
Yeah,
here,
ma'am.
if everything is clear, if the MCQ question will be there, that will ask you what is the class mark of this interval, what is the class size of this interval, what is the draw the histogram, what is the relation between area and frequency. These all the data you need to know really well to answer the question. One more thing will can be there, that if the basic raw data is given, the raw data is, suppose I am giving you the marks of the student, one of the student got 15 marks, another got 10 marks, another got 13 marks out of 20, out of 20 another student got 18 marks. Okay, what is the range of the data? See, this range is also important. They think that you have learned the these basics in the previous class. So range of the data means maximum data point minus minimum data point. Making sense?
Yes, ma'am.
Okay, here the range of this data, for example, which I was giving, maximum is 18 and the minimum is 10. Range of the data will be 18 minus 10, that is 8. Making sense, Nikhil?
Yes, ma'am.
Okay, and what about this group data? What will be the range over here? So here also we can take the range in the same manner, that the maximum is 180 and the minimum is this. So range will be 180 minus 118. Clear?
Yes, ma'am.
Okay, so yeah, this is how we find the range of the data. And yeah, rest of the terminology we have discussed already. Just frequency polygon I'll finish and we'll be done with statistics. Okay.
Okay,
So
ma'am.
yeah, I am keeping this much over here. Let's continue with frequency polygon in the next class. Any doubt so far, Nikhil?
No, ma'am.
Okay, so yeah, keeping it this much. And yeah, thank you. Take care. Bye.
Thank you, ma'am. Bye, ma'am.
Thank you. Bye.